Cool. Well, my name is Isaac, and I guess for the next hour, I'm going to guide you through some of the open source tools that we've been working on and releasing. Um, I guess by way of background, I'll tell you a little bit about myself. So I started getting involved in security working with the government on a scholarship for service program. If you're familiar with the tool Ghidra, which is a reverse engineering tool that the government, the Defense Department, declassified and open sourced about a year and a half ago now. I used to work on the team that developed Ghidra, which was a lot of fun. So I love reverse engineering, love program analysis, all that sorts of stuff. But I'm really here also representing a broader team, some of whom are pictured here. And we come from places like the Facebook security team, security consultancies like NCC Group, academic places like INRIA. And our work is really about trying to figure a way to automate security for developers. So the way that we've been trying to do that is by releasing open source tools that developers can just adopt for free, and then providing commercial services for enterprises on top of those tools. So sgrep is one of them. It's all free and open source, and that's going to be the main focus for tonight. So sgrep is really a rule engine. It's basically designed for people who have an idea of what they would like to catch. So if you are a red teamer or a blue teamer and you want to look for bad patterns in code, you've come to the right place. We also have a different tool, which is more developer focused, which is kind of, well, if you just want to use the rules and the patterns that other people have already written and run them at pre-commit time or in CI and capture feedback, there's a different tool for that we won't be talking about, but it bears mentioning. So what is sgrep? The S in sgrep stands for originally syntactical, but now increasingly semantic grep. And I'm going to start off with a motivating example that I think will be familiar to a lot of you. So this is a snippet from a piece of source code from a Python application, obviously using the Flask web framework. And if we look at this, we see that the developer has explicitly chosen to set the secure flag on the cookie to false and the HTTP only flag to false. So this cookie will happily be transmitted over an HTTP connection, whereas we would really like it to only go over an HTTPS connection, which is not great. And if we're finding one of these things when we're looking at the source code for an application, there are probably going to be more. So like any good security engineer or hacker or researcher, we want to find all of them if we can. And so we're probably going to reach towards a tool that we know already, which is grep. And before I show you the grep invocation that I'm about to write, just to make this a little bit less abstract, this was actually a bug that was found in Netflix and reported via Bugcrowd in March of this year, so less than a month ago. Super relevant. The sgrep, sorry, not sgrep, but the grep pattern that we're going to try to write first is probably going to look like this. So grep-r response.setCookie. We're going to need to escape the parentheses. We'll do a dot star. Secure equals false, dot star, backslash, parentheses, and then search that over the whole thing. Well, immediately this is probably going to run into a few issues. First off, it's going to search every file, not just Python files, and we might want to fix that. So we'll switch to ripgrep, which is a great, much faster, actually, alternative to grep. It has some nice features that make it easier to filter this down. And here's our second attempt. So this should be a good deal better. We're not triggering on things inside TypeScript or JavaScript files. If it's a monorepo, that might be mixed in. That being said, we're still going to run into some interesting issues. So one by one, the first thing is, what if the developer has indented or added a new line and we have a multi-line pattern? Well, grep isn't so great for that. So now, we're going to have to extend the grep expression. And then also, what if the developer said from Flask import response as R, and then they said r.setCookie? Well, we wouldn't match that either. And in fact, that's going to be really obnoxious to catch with grep. And then there's also comments. So if there's like a pound sign in front of the line, we should really be ignoring that. We wouldn't want to comment on commented out code. And then also, since this is Python, secure and HTTP only are keyword arguments. So you can actually put them in any order, not the order that we specified in our grep expression. And also they're optional. So you might just specify secure equals true, and you might just specify HTTP only. So this is a relatively simple example, and certainly grep is going to find many of these patterns inside the code base. But if we want to find all of them, or if we want to set up a workflow where we could give this to the developers and be like, hey, like run this grep expression every time you check in code, it'll find this issue and tell you what to do. It's going to be kind of problematic because of all these corner cases. And I think it really shows, the limitations of regex. And of course, there's an XKCD for this. If you're having pro problems, I feel bad for you, son. I got 99 problems, so I used regular expressions. Now I have 100 problems. So when we think about regular expressions, how can we do better? Well, what we're facing here is that there's a fundamental mismatch between regular expressions, which are designed to operate on strings, and how the Python interpreter really thinks about this program, which is a tree. So we're using something that is designed for parsing and manipulation on strings. It's doing great for that. But what we really want is something that can operate on the tree structure of the parse program. So for those who aren't familiar with the terminology, one of the first things a compiler or an interpreter does is it lifts the just string representation of the code into a tree that looks like, I've put an example here of actually the Python AST view of what the tree of that program looks like. So AST stands for abstract syntax tree, which just means that it started to lift the program into a representation that can be used by a compiler. So what are our options? Well, we've explored grep. The pros are it's easy to use, it's interactive, it's very fast. In theory, it supports an infinite number of languages, but the cons are significant. So grep is fundamentally line-oriented, and as we just talked about, it has a mismatch with the program structure. So the things like the trees and the ASTs, which are really what fundamentally make up a program. So our next option is probably to seriously upgrade. It's time to use a real parser to inspect this code. The pros of this are going to be that it's very robust. It's going to be very precise. It's only going to trigger when these things actually happen. But there are a number of cons to this approach as well. The first one is that unless you are working at a company which only writes one programming language, unlikely, you are going to need to go find a good parser for each language. So for JavaScript, you might use Babel. For Go, you might use Go AST. For Python, you might use Python AST, which is a built-in. But you're going to have to find one for each language. And then also, each of these parsers is going to represent the AST differently. So the way that a JavaScript AST looks, the names of the nodes are going to look different than the way that the Python or the Go ASTs look like. So we're going to have to figure out how to learn and write matchers on these ASTs differently for each language. And then the other con is that these languages oftentimes have more than one way to do it. So we're going to need a lot of language expertise to understand what are all the variations on the ways in which you could invoke a method inside JavaScript. What are all the ways that you could do it inside Go? And so in this world, sgrep is sort of an in-between solution between using a real parser and using grep. And just to give you a little bit of background on sgrep, so it's a free tool for writing lightweight checks using code as the pattern to find bugs with a familiar syntax. Sgrep already supports Python, JavaScript, Java, Golang, and C. PHP and TypeScript, along with a couple other languages, are in the works. And just to give you the full context, so the first version of sgrep was actually written at Facebook, where they use it to enforce almost 1,000 rules. Facebook open sourced it, and the original author of sgrep, Johan, who was actually the first program analysis hire at Facebook, joined R2C last year. If you're familiar with a tool called Coccinelle, which was one of the first refactoring and static analysis projects for the Linux kernel, Johan was also involved with that project during his time at INRIA in France. So let's see how sgrep would approach this problem. And for this, I'm actually going to switch over into a live editor that we have. I think that the screen should be coming through just fine still. Let me know if that's not true. So I've got the snippet of code that we were talking about earlier. You can see I've even added a comment to see whether or not we're going to trigger on that. And in fact, it's not as simple as just grepping for flask.response.setCookie because we have an import that's bringing Flask in. We're not using the fully qualified name. So in the sgrep world, if I want to trigger on all of the setCookie calls, I can basically do this. I can say flask.response.setCookie, and I will put hello world there, and then I'll run this. And you can see pretty fast, we came through, we've got an output here, which is matching. It's just color-coded, so it's easier to see. it's matching this call to hello world right there. So just to make that explicit, what happened under this hood was that sgrep took this input string, it parsed it into a tree-like representation, turned that tree-like representation into a tree matcher, and then it ran that tree matcher across the tree representation of the source code that we have down here. So that's pretty cool, but we haven't really solved our problem yet, because what we really want to do is trigger on any of the cases where secure equals false or HTTP only equals false. So I'm going to show you a bit of syntax. So there are two things that you need to know about sgrep. The first one is the ... operator. So if I put ... that just lets us match any number of arguments, basically. So I can go through ... and now every instance of response.setCookie here is being highlighted, which is great. Also, this one is not being highlighted, also great. That's commented out code, we don't care about it. And now I want to basically say, well, okay, I don't care about these other arguments. I just want to trigger when secure equals false. So to do that, kind of exactly like what you would expect, I'm just going to put secure equals false in there. And the cool thing, just to again illustrate to you that this is not grep, I can put white space in this expression. It'll work just fine. It doesn't care about that. So I'm going to flip this around, and I'm going to try to find this section. Oh, I see there was a comment in the chat. Is there a way to make the Chrome window a little bigger? Yeah, I think so. All right, I'm gonna keep going. Sound off in the comments if I can make it even clearer. So I'm gonna try to find this one where HTTP only equals true and secure equals true inside the code. So what I can do is I'll change this. I'll say secure equals true, HTTP only equals true, ... Boom. Now I find this one. And now for something really cool, remember these are keyword arguments in Python. So in theory, the order shouldn't matter. I should be able to write my query with HTTP only first and secure second, and it should still match this line of code. So if I run that, boom, in fact, this does work. So we'll come back to the sgrep live editor, but I just kind of wanted to give a quick zoom in. Oh yeah. If you are on the Zoom, you should be able to zoom in on my screen by hovering over to the left. So that was a really trivial example. Now I'd like to show you an example that's a little bit more interesting and complicated. So let's say that we are looking for this sort of pattern where Boto3, which is a library for interacting with AWS S3 resources, if you're not familiar with it, we want to find all the instances where somebody is going through and hard coding the secret access key inside Python. Just to give you a sense of the sort of trade-off and pros and cons, because sgrep isn't for everything, on the right, I have the Flake 8, which is a Python AST visitor check that you would write. And in fact, this was a check that was written by some folks on our team in order to find this specific issue before we developed sgrep. So if I switch over to the sgrep live view of this, hopefully it should be fairly obvious to you what that pattern would look like in sgrep. But I'm basically going to say boto3.client on that. I'm just going to verify, yep, looks like that is triggering on this one. But if I copy this, let's say there are some that are actually using an environment variable. So I don't want to trigger on those. So os.env, ID. Assuming I've got my syntax right, we're triggering on both of these two patterns right now. So that's great, but if we wanted to write a query to only look for the one that has hard-coded strings, we would basically do this. So we would say AWS access key ID equals, and then we can reuse that ... operator that I was talking about to actually match a sequence of characters. So we're just saying we don't care about what's involved in these characters. And I'll just copy paste the name of this variable in here as well. Boom. So now we filtered it down, and we're only triggering on the second instance there. If you're thinking to yourself, okay, that's pretty cool, but how can I know whether the like hard-coded is it a high entropy string? Hang on to that thought. We will come back to it later. And yeah, so there's the sgrep pattern that we just used to find this issue. I'm going to pause real quick and just check to see, are there any questions about what what I've presented so far? I know I've been going a bit fast.
Yeah, Isaac. This looks awesome so far. I just had a question on, do you do any kind of like variable substitution? So um, if you had a global variable that was set to a hard-coded string and then use that global variable for the key ID, is it possible to find that using sgrep?
Yes, it is. There are some limitations,
Uh-huh.
and I will show you some examples of that later on. But we want to remove most of those limitations.
Mhm.
So I'll actually have a whole slide on what we call the like semantic equivalences. So like you see pattern A, but it's really the same thing as pattern B. In the ideal world, sgrep just deals with that abstraction for you, and what you're talking about is exactly an example of that.
Awesome. Thanks, Isaac.
For sure. Cool. So now we're going to get into like the heart of the talk. So I've sort of given you an introduction to the tool, the motivating use cases. We actually already talked about one of these operators, but I'm going to give you a more thorough view of it in this part of the talk. So we already talked about the first bit, which is that this is not grep. It doesn't care about spacing because it works at the AST level, not the character level. It doesn't care about comments. There's some examples here of the horrifying ways in which if you were trying to write a grep expression for the third thing or the fourth entry on the right in particular, it would be a complete nightmare. But you don't have to deal with those sorts of limitations. The second thing, which I haven't shown you yet, is metavariables. So metavariables let you basically introduce a $X, $Y, whatever, and match arbitrary things in the code. So I can say foo $X, comma 2. That's going to match foo with 1 or really anything, comma 2 as the second argument. I can use that not only in function arguments, but as the conditionals and if blocks, as a list of statements inside an if block, inside names of functions, fields, classes, etc. And where this becomes really powerful is you can actually reuse the metavariable to enforce equality constraints. So here's some examples of patterns. These are actually patterns that are surprisingly effective at finding bugs. And we're going to come back to this in a minute. But like $x equals X will match A plus B equals A plus B. If $E, $S, else $S. $S is greedy, so it's going to match a list of statements. So if we have an if block where the consequent and the antecedent are the exact same, it's going to match that. And it can also be used to express some flows. So if I have like $V equals open and then $V close, I can express that as well. So metavariables are super cool. Here's a fun example. This is an actual bug that we found inside Apache libcloud. So I'll give you a moment to look at it and see if you can spot it before I highlight it. I'm pretty sure this one has since been fixed. But what's going on is node underscore ID was what was passed in as the argument. But then this comparison operation on the right here is just always going to be true because they meant to use node underscore ID. Instead, they use node.id. So sgrep $x equals X will match that, no problem, because this is the exact same element being represented on both sides of that equality expression. So the next thing, which you already saw some examples of, is the ... the ellipsis operator. And just to make this really clear what it can do, so you saw examples of it matching arguments like foo ... comma 5. That's going to match these two examples on the right. It can match a sequence of characters. So we saw that already with the hard-coded strings. And then it can also match a sequence of statements. So if I have $V equals get ... eval $V, that will match all of the intermediate statements in between the get and the eval. So you can use that. I'm sure you're imagining, if you fetch something from a user request and then you drop it into some sort of dangerous sync like a system call or something else. Any questions on the metavariables or the ellipsis operators? Cool. All right. I am going to now get into the really cool part, which is some of the code equivalences that are implemented in sgrep. So the first one we talked about a little bit, $x equals $X. This one's actually disabled by default, and there's a hidden flag that lets you turn it on. But in some languages, this operator has the property that if you say a plus equals a plus b, not equal a plus b, that's the same as saying not, and then the parenthesized expression a plus b equals a plus b. So if this equivalence is enabled, sgrep will actually match this left-hand pattern with the not, even for this pattern over here, because it understands that those two are equivalent. We already talked a little bit about the Python kwarg example. So I guess the cool thing here is that sgrep is lifting the languages into a generic representation, but it knows about the semantics of each language, and it doesn't forget that information. So this, kwarg being unordered is specific to Python. That will not necessarily, it will not apply to C, for instance. Similarly, it has really cool support for import resolution. So we saw that a little bit in the Flask example. But if I say subprocess.open, that will still match something that is not only importing it under a module, but is aliasing the import. The one thing there is that if you just grep for subopen unqualified, you actually really want to grep for this original thing, not the subopen expression, because that's going to be overly specific. And one of the cool things, which is maybe like seems easy, but it's actually really handy if you're doing security research, especially, is that the imports all get normalized as well. So if you want to know, hey, show me all the files that import foo.bar, you just type import foo.bar, and all sorts of variations of from foo import bar, from foo import bar2, bar3, bar will be matched by sgrep. So not everything has an equivalence, right? There are some things that are too complicated to represent, and there's a performance cost for implementing them. But we've put a lot of work, especially for the languages that are supported, Python, JavaScript, Java, and Golang, to add a significant amount of equivalences. And one cool example I will show you there is constant propagation. This is what the earlier question was about. And I'm actually going to switch us over. So on the live editor, I've selected Go as the example. If you're not familiar with Go, no worries. This is going to be a very, very easy example just to make it super clear what's going on. So if I type dangerous1, and I put dot, dot, dot inside the string here, that's going to come and match this first one here. But I would also really like if I switch this to dangerous2 for that hard-coded string, because this is defined as a const inside Golang, for this to still match. And in fact, this wasn't present in the original version of sgrep, but as you can see, we've actually made it work in, I think, as of the release that came out just a couple of weeks ago. So this is a pretty recent feature. The current implementation only works for constant propagation. So it works in languages that have a const keyword, so like JavaScript, Golang. It does not yet work in Python because Python doesn't have a way to specify a variable as a const. But that's something that is coming up. So yeah, now that I'm not in full screen mode, I can see some of the questions. So I will answer those real quick. The flow is tracked. The question is, how do you track the flows? Is that done using taint analysis? The taint analysis, so taint analysis is a form of data flow. There is some limited data flow going on inside the system. We do not yet have a full taint analysis implemented. And I mean, this is sort of one of the trade-offs that sgrep makes. If you buy a commercial tool like Coverity, for instance, Coverity spends a lot of compute resources to construct an interprocedural, so it goes across files, very detailed data flow, which allows it to detect some really interesting bugs. Sgrep is not really designed to do that. Sgrep is designed for very, very fast use cases where you want to present this information super quick to the developer. You want to do it, like in their editor. You want to do it in pre-commit. You want to do it in CI. And what we found is that a lot of teams, like they buy a really expensive static analysis project, but if it takes, hours or even days in some cases to run, teams are deploying software faster than that static analysis tool can actually run. So sgrep is more designed for those sorts of use cases. And then I see there's another question about how is this better than linters? Well, it's sort of complementary, I would say. The really interesting thing is that, the flake8 example that I showed earlier, so that is the sort of thing that you would put in a linter. Flake8 is a plugin for linters. And in fact, the tool that I mentioned at the start, Bento, is basically a meta linter. It includes a bunch of other different things. The primary advantage here is that it's just way easier to specify using a pattern rather than having to write and learn the AST syntax of a bunch of different languages, which is what you would need to do if you were trying to implement some custom linting rules. So again, sgrep is really designed for people who, rather than just like using some generic framework, you have a framework that you care a lot about. Hey, whenever this happens inside this framework that I know a lot about, there's going to be a security issue. Sgrep is a great candidate. If you just want a bunch of prepackaged rules that are sort of the standard road that everybody else is using, a linter is great for that. So, not here to denigrate the linter world at all. In fact, some of the people who are sgrep users are linter authors who are interested in just finding lighter weight, cheaper ways to express the sorts of patterns that are very complicated to express when you are trying to, when you have to parse and deal with all of the AST internal representation. So I hope that answers the question. Happy to chat more about it. So the second bit actually touches on some of those questions. So we've seen how to write some basic patterns, but if you wanted to actually roll these out to your team, you need a lot more, right? You need the capability to specify messages, probably want some like Boolean logic that lets you, well, in this case, that's okay. So I want to see either this or this or this combined with this, this sort of complicated config stuff. So at RTC, we have a platform that lets us take these rules and run them over massive corpuses of data. So for instance, the rule that I showed you that found that libcloud bug, we ran it over the top 5,000 packages on PyPy in a few minutes and looked at the results. And we can scale this up to like every version of every package on NPM or most of GitHub, which is super cool. So I'll show you a little bit what that looks like, and I'll start by introducing a little bit more sophisticated syntax for specifying the patterns. So here is a YAML file, and if you want to run this right now, I guess I should have mentioned, you can go to sgrep.dev, and sgrep is packaged in a Docker container, so feel free to do that right now. You will need the Docker daemon installed. There are some binaries that are not quite ready yet. And you can follow along if you'd like as I go through this. So the YAML syntax is basically, you've still got the pattern in there, just like we were using in the sgrep live editor. And then the cool thing is that you can specify a message. And actually, the message fields, the metavariables that you use inside the message, they'll get populated with whatever is found inside the source code. So if we do this and run it, what we'll see is 1 = 1 is always true. That's the message that the developer or you as the user of the tool will see. Now, when we start running a tool like x = x over the entire PyPy corpus, basically we see a lot of test code, which is not great. So we kind of want to say, hey, yeah, I want to find these sorts of things, but really not when they're inside an assert. And so in the YAML syntax, we can nest two patterns. So we can say pattern not inside assert ... and then specify our pattern. And in fact, that's all we have to do to get rid of the case that's over there on the right. You can scale this up. You can nest the patterns to your heart's content. So here is actually the one that we used to find the libcloud bug. It found some other bugs in Scapy, which is a packet inspection library, and in the Azure SDK, which were pretty cool. And you can see we've specified a much more detailed message, something that you would feel confident putting in front of a developer that actually gives them some actionable suggestions, or hey, you could do this, instead of the pattern that we've noted here. Again, this is not perfect, right? Like this is still going to have some issues, but having run it over many thousands of Python repositories, we actually have some internal tools that can give a really detailed report on the confusion matrix. So how many false positives does this find? How many true positives does it find? And really what we're trying to do is give teams that, they want some custom analysis bits, and they're looking for a tool like grep. A tool like sgrep should be a really obvious upgrade path from where you're at. Any questions on the YAML syntax? I'm gonna have to exit the full screen mode to see the questions. All right, so the next thing, which is, oh yeah, go for it.
Any reason why you chose YAML as opposed to like implementing a more expressive like DSL for this type of thing?
Laziness.
Okay.
um, so yeah, I mean, the interesting thing is that the YAML stuff is actually a completely separate project from the sgrep core. It's still in the same repository, but the sgrep core just outputs JSON. And so all of the YAML stuff is just invoking the sort of lib sgrep with these patterns and then doing Boolean composition. So in no way are you limited to using the YAML to do the composition of Boolean rules. In
Okay.
fact, we might consider doing some other kind of DSL. I think a lot of people are just kind of comfortable with YAML, so it's a reasonable start.
Fair enough. Thanks.
But it has its frustrations. I will tell you that. So the other thing that we haven't really talked about yet, most of these examples have been in Python. You can just change the language tag inside the YAML file here. So if you go back, you see that the languages is actually an array in Python on that one. Here we've switched it to JavaScript. One of the crazy things is that because so many languages share syntax, this rule would actually be valid JavaScript and C, and as well as a couple other languages, which is kind of cool. So in theory, you could take a pattern which creates a generic AST matcher from one language, like for Python, and apply it to a completely different language, like Bash, which is sort of bizarre, but it's possible. And it's just as easy as changing the language tag here. So that's just going to say, use the JavaScript parser to parse this pattern rather than the Python parser. The other thing, which I mentioned I would come back to, is that because the YAML parsing code is implemented in Python, it actually has the capability to be really scriptable. So here's a real example of something that we wrote up for the registry, which I'll touch on in a minute, which is basically encouraging people to use a decimal field for money inside Django or Flask web applications. So we're saying as long as the pattern is inside some kind of class and you're assigning some sort of field to be equal to the results of django.db.models float field, we can actually have an arbitrary Python snippet that will use the results of the metavars. And here we're doing just a very basic check. We're saying, hey, is price the name of the variable f that was assigned here? But like we could pass that off to an external service, like for instance, with that AWS example, something that's telling us the entropy of the string and make a decision about whether or not we're going to report on it in sort of our custom logic. So this is actually this is another thing that we added recently to sgrep. Actually, it was somebody from NCC Group who helped contribute this feature, and it's really powerful. To my knowledge, there's not a lot of other analysis tools that have this level of scriptability and pluggability. Now, the one caveat here is, well, okay, we're all security nerds. Isn't this executing arbitrary code from that config file? Yes, it is. So if you're actually going to use this, you have to set a non-default flag, which is dangerously allow arbitrary code execution for rules. If you are using sgrep in sgrep.live, you might notice that some of the rules seem to be running just fine, even though they are using this arbitrary scripting thing. That's because the rules that we've put into the registry that get accepted, we've actually manually vetted. And so there's some code signing effectively going on that makes those safe to run. Any questions about the scriptability or the language tags? Cool. So there's a question about with LLVM becoming extremely powerful to identify and optimize away patterns like x equals y, y equals z. Where do you see the benefit with working with a language like C? That's a good question. I mean, that's a fairly trivial thing, right? You wouldn't necessarily care about it in a lot of languages, not just C, because it'll get optimized out. I guess what I see as really interesting with sgrep is we actually had a user who we were talking to last week who is a security researcher. He'll remain anonymous, but he had a lot of knowledge of libcurl. And so he was using sgrep to basically identify patterns where people were insecurely setting up the curl API, especially when it came to redirects, which is, of course, a pattern that you would usually see in C code since you're talking about libcurl. And what sgrep allowed him to do is just really cheaply kind of express, hey, when people call the curl API with this parameter and this parameter looking like that, but not this other parameter, then it's definitely going to be a security problem. And what I think is kind of cool is that, the whole idea here is just make it really easy to share rules. I'm actually going to show you in a minute how you can just you can send a rule to a registry right from sgrep.live. And so we really kind of want to make it a way to spread domain expertise, in the language that you care about. So, there are trivial patterns like that. And also, I should note LLVM is a great project, and there are a lot of things that it's going to make way more sense to implement this as an LLVM compiler pass or a Clang front-end pass in particular. The Clang front-end has a lot of really, really good capabilities. So sgrep's not for everything. Actually, at the end of the presentation, I'll cover some more of the use cases where I think it really shines. Cool, so I've mentioned this a few times, but just to come back to it, there is a rule registry. So when you invoke sgrep, you can pass a config option, which you can give that a YAML file. If you give it one of the keys like R2C, that will automatically pull from a curated set of sgrep patterns that live at this GitHub repository. So currently, there are examples and tests for Java, JavaScript, Golang, and Python. And one thing that I'll show you, which is pretty cool, so coming back to the very first example that we use, we had this Flask response thing. Here is the finished pattern that has a very detailed message that can be displayed to the developer and has the patterns that we care about. So we're basically saying, if you're explicitly setting HTTP only for true and secure equal to true, then we're not going to report. And on all other instances of set cookie, we'll report. So if we run that, we see, yep, that passes. There's actually a syntax to specify the test suite inside this, which is pretty cool. And then there are a bunch of examples that you can load up, which are from the registry. You can also share it. So you can put the presumed check ID here. And if you click this button, it'll make an automatic pull request to that repository, which is super cool. So we're just trying to make it easy, for people to share things with the community. And also, if you do contribute the rule to us, we'll include it in the regression suite. So, it'll be noted as a breaking change if we decide to make a syntax that makes the rule that you wrote more expressive, for instance. So if there's some equivalences that come out, which change the behavior. So there's some really cool contributors who are working on this rules repository. Obviously, our team is working on them. We've had some real ideas contributed by people. One of the co-founders of the Django project, the Flask team, as well as a bunch of just independent security researchers. And one of the things that we're doing behind the scenes is, I mentioned this platform that we have to scale up. We're trying to do check quality assessments. So figure out the finding rate, the action rate, simulated across a bunch of historical commits. Are people, is this pattern actually high signal? What are the ones that appear to find things that developers are fixing versus they find things that developers really don't fix? Any questions about the registry? So we're getting pretty close to the end here, but I just want to touch a little bit on integrations. So I mentioned this at the start. sgrep is currently one of the engines inside Bento, which is our open source meta linter. It packages sgrep with a lot of other open source tools. For instance, the author of Bandit is a friend of the company, and that's one of the tools that we've packaged inside Bento. And there's actually another tool, which is a little bit newer, which some of you might be familiar with from Duo Security, called dlint. That's also included in Bento. And I guess the author of dlint just joined us in January, which is super cool. So Bento is really more focused on the developer use case. It can automatically set up pre-commit hooks. It can automatically set up a GitHub action. It's kind of the thing that you would want for team deploys. We're trying to keep some of that out of sgrep, keep sgrep to be a really clean, light tool. If you're familiar with the Salus project at Coinbase, we actually have a pull request that's in progress to get that added to Coinbase, which we're really excited about. And then also, if you look at the docs for sgrep, there is a pre-commit hook. There's a GitHub action if you just want to use that directly. And if you had a flow that you wanted to integrate it into, you can just run sgrep-output, put your URL, and it'll post the JSON output directly there. Of course, there's also a JSON flag that it will just output JSON so that you can pipe that into whatever system you desire. So what is going on with the future of sgrep? It's maybe a little bit difficult to appreciate, but we had our first sgrep meetup in December of last year. At that point, we had just added Python and JavaScript support, and none of the other equivalences or other things that you saw tonight had really been done. At Facebook, it only had support for PHP, so all of the modern language stuff has been new work. One thing is, Docker is great. Hopefully you're having a good experience with that right now as I've been chatting, but we would really like to make this just binarily installable, so make it available on brew and on apt. We would like to make it possible to define more code equivalences easily. So for instance, depending on the type of the object, x plus y might be totally equivalent to y plus x. That's a very obvious, easy thing to add. There's active work underway to make that possible. Some of the things that are coming up after that are integration of typing information. So for instance, in JavaScript, if I wanted to say, hey, I'm looking for a new buffer constructor where the first argument is an integer, I should just be able to reuse the TypeScript syntax in the query and have that be applied to JavaScript, even if that JavaScript doesn't have any types at all. And the second piece is actually, somebody touched on this earlier, but actually integrating tainting information from a proper taint tracking analysis, so that I can say, hey, I want to find all the flows into something like eval, where the argument comes from some sort of user data tag that I've defined. So those are all projects that we have. There's another big project to support a whole bunch more languages. So if you're familiar with the tree sitter project, which it lives at GitHub right now, there's a GitHub employee who's the main maintainer. Tree sitter is a generalized parsing framework which is heavily optimized for incremental updates from a changing buffer, which basically means it's designed for use in the editor. So it's super, super fast, which is awesome. And we are working on switching, a lot of the parsing logic is fairly old. So, like sgrep was started at Facebook back in the early days of Facebook. We're working on switching the parsing support to use tree sitter, and that will automatically give us support for about 30 more languages, which will be super cool when it finally lands. So I think the last thing to talk about really is, how can you use this? So the most obvious one that you've probably been thinking of already, and maybe you've already started doing this, is find bugs in code. So use something like $x == x. Use the sgrep rules repo for ideas. There's a bunch of stuff in there. We have an internal CVE trophy case, which is not quite ready to be public yet, but once it is public, we would love contributions to that, CVEs that other people have found, of which there are already a couple using sgrep. When you think about it in the context of a team, like not just red team, I think the most valuable usage of this is to enforce secure defaults and secure frameworks at CI time. So if you as a security team are like, hey, there's a way to open a file at my organization, or there's a way to, like a wrapper that we always use before we send a request back to the user, sgrep is an excellent way to basically provide some advice to the developer. And there are integrations in tools like Bento, which will let you make GitHub comments and things like that automatically, so that you can just say, hey, like tagging a security person here because you're using a function that we feel like is really, really scary. sgrep is great for the God mode function inside your organization, just being able to find that. Another use case that some people have explored is basically narrowing vulnerability reports based on usage. So for instance, if you are a GitHub user, you've probably gotten spammed within the past couple of months or sometime last year by people or bug reports about like vulnerabilities and third-party dependencies. The median vulnerability report, if you think about it, this kind of makes sense, is a very low impact vulnerability in a very popular library. So for instance, I think the one that spammed me the most was a bug in Lodash, which is the most popular library for JavaScript. Lodash has like 100 functions in it, and this prototype pollution vulnerability only affected one function. So we actually used sgrep to just get a sense for like, oh, how many people is this a false positive, like useless report for? And the number of projects that used Lodash but didn't use this function across the GitHub corpus was like 99%. So when a new vulnerability comes out, a potential use case is, hey, use sgrep to figure out, are we actually even using the function that has that vulnerability? How concerned should we be? I want to make sure that we leave plenty of time for questions, but sgrep.dev just redirects to a GitHub repo. There are more cool tools that we're working on. This is sort of just the tip of the iceberg, so feel free to follow us on Twitter if you want more of a stream of that. And we would love your contributions to the sgrep rules repository. We accept PRs from anybody. We have a Slack. I think some of you are actually already on that, where we try to be really receptive and helpful about if you have questions or you're trying to figure out a pattern. We've done our best to make it easy, but to be honest, it can always be better. So good feedback on like, hey, this is really confusing is great. We will not be unfriendly. And if you have other examples of, oh, like I feel like this is a really cool pattern that I would like to catch, we would love to hear about things like that. So yeah, have about 15 minutes for questions. I'm going to go to the chat room real quick and just start looking at those. So from Ajin, hi Ajin. Ajin's the author of Node.js Sec, which is one of the Node.js SaaS tools. I think it's the default in GitLab right now. So super cool to see that. And the question or maybe comment is that it would be great to get it in a Python library as well. Yes, that would definitely be cool. There's a question from Miguel about how we deal with AST API instability in some languages, like in Python. Two ways to interpret that question. The first is, like if you use the built-in Python AST module, the behavior of that module is dependent on your major version of Python, at least potentially your minor version of Python. We are using our own Python parser, so we don't have to deal with like the internal Python AST implementation changing. That being said, of course, Python adds new features from time to time, and like for instance, the 2 to 3 transition was a big deal, and so like you can't use a Python 3 parser for Python 2 code or vice versa. The real answer here is that we use the platform. We basically measure what percentage of files are we successfully parsing across a giant corpus of stuff on GitHub. So for currently our Python parser is at something like 99.99%. I hope that answers the question and the intention that was asked. And then from Genevieve, there's a question about, are we building automatic forensic or IR tools with sgrep? No, we're actually not. Even though like reverse engineering is part of my background, it's not something that is sort of like a real specialty of the team, I would say. Totally open to that being an application, and we would love to support other people building more things on top of it. Yeah, so I think that that about wraps it up. Feel free to play with sgrep.live. This is all actually super new. This just got stood up in the last month. So there's a way, if you ever, like if you run into something and you're like, I feel like this should match something, it'll link you to the config documentation, which we're always working on improving. But if it's actually wrong, then you can just click this button to report a bug. That'll automatically take you to our GitHub. It'll even put a link to the sgrep.live repo. So we're just trying to make it very, very easy to get started with the tool, and we'd love contributions. I guess in terms of contributing to the source code itself, one thing that I didn't mention, sgrep core is written in OCaml, as are most of the program analysis tools that come out of Facebook. But the like YAML parser and the Boolean logic and all of that other stuff, like the posting to Slack outputs and things like that, are written in Python, which are a little bit probably more accessible for people who are coming from the security community as opposed to the program analysis community.
That's cool. Thank you so much for your great talk.
I really appreciate the invitation. Hope to come back when we can all meet in person.
Sure, definitely. All right, everyone. Thanks for joining. This is the end of the night.